Hello everyone, I'm Arpita Pandey and in this video I'll be explaining my project called Indian Food Intelligence System. This project is a machine learning based application that can predict the diet type of a dish, recommend similar food items, and provide intelligent insight based on ingredients. So let's begin with the dataset. I have used an Indian food dataset which contains columns like recipe name, translated ingredients, cuisine, and diet. Recipe name represents the name of the dish, translated ingredients contain the ingredient used, and cuisine represents the regional category, and diet is the target variable which tells whether the dish is vegetarian or non-vegetarian. The most important column for this project is translated ingredients because it captures the actual composition of the food. This allows the model to learn patterns such as paneer being associated with vegetarian and chicken being associated with non-vegetarian dishes. So before training the model, we analyze our data set. Now let's move to the implementation of our model. And now let's move to our Google Colab file. This is our Google Colab file. Okay, so first I imported the required libraries. I used pandas for data manipulation and analysis, NumPy for numerical operation, and scikit-learn for building machine learning models. From scikit-learn, I used TF-IDF vectorizer for feature extraction, then train test split for splitting the data set, and different classification models like logistic regression, random forest, and linear SVC. So here you can see we have loaded our data and all the columns required. Then we have done the common pre-processing um, and feature preparation. I selected translated ingredient as the input feature and diet as a target label. Since the input data is textual, I applied TF-IDF vectorization. TF-IDF stands for term frequency inverse document frequency. It converts text into numerical vectors by assigning weight to words based on their importance. Words like paneer, chicken, or fish gets higher importance because they are more informative, while common words get low importance. These steps help result in a high dimensional sparse matrix where each feature represents a word. After this, I split the dataset into training and testing set using train test split. This allows me to train the model on one portion of the data and evaluate it on unseen data, ensuring that the model generalizes well. Now let us move to the models we used. We have used linear SVC, logistic regression, and random forest. Logistic regression is a linear model used for binary classification. It is simple, fast, and easy to implement. Here, next we have used random forest. Uh, TF-IDF produces very high dimensional and sparse data. Logistic regression may not capture complex decision boundaries effectively, so which might reduce the accuracy of in our model. The second model is random forest. Random forest is an assembled learning method that builds multiple decision trees and combines their prediction. It is powerful and can capture non-linear relationships. However, for text data, random forest is not very efficient because decision trees do not handle sparse, high-dimensional vectors well. And our last model is linear SVC. Linear SVC is based on support vector machine and is particularly effective for text classification tasks. It works well with high dimensional data and finds the optimal hyperplane that separates classes. Here, all three of them have given different accuracy. So let's see. First one is linear SVC. Linear SVC gave us 76.56% accuracy with this table for precision recall and F1 score. Next is logistic regression. It gave the accuracy of 75.87%, and the random forest gave us accuracy of 74.67%. Because of this efficiency and performance, we selected linear SVC as the final model and optimized it further. Um, let's see. Okay, so for optimizing it more, we did three steps. First, I improved feature representation by using TF-IDF instead of simpler method like bag of words. Second, I ensured proper pre-processing by cleaning the data and normalizing text. Third, I experimented with multiple models and selected the best performing one based on accuracy. So after all of this, we got the accuracy of 78.04%. Additionally, I used cosine similarity along with DFIDF vectors to build a recommendation system which enhances the overall functionality of the application. For the recommendation system, I used cosine similarity to measure how similar two dishes are. Cosine similarity calculates the angle between two vectors. A value close to 1 means high similarity and a value close to 0 means low similarity. I compare the user input with all dishes in the dataset and select the top 5 similar dishes. I also convert similarity score into percentage and display them using progress bar to make sure the results more interpretable. Now let's see our demo example on the our deployed GUI. Here let us enter the um, ingredients. I have entered onion, paneer, tomato, and butter. So let's analyze it. After analyzing, it has predicted the diet as high protein vegetarian and also recommended us similar food items with the percentage matching. It has given us 5 food items such as paneer bhurji recipe and with matching of 30.94% and 4 others. Other than this, next to the food insights module, instead of calculating exact calories, I implemented qualitative analysis. This is because calorie calculation require quality and preparation detail which are not available in the input. So instead, I detect keyword and assign tags like high protein, high carb, or high fat. This approach provides meaningful insight without giving misleading numerical values. Here, the input we gave us high protein and high fat, and the insides are good source of protein and may be heavy to digest because of the ingredients we use. This is the GUI for it. It predicts diet type, recommend dishes with match percentage, and food insights with health tag. All results are shown in a single page, ensuring a smooth and intuitive and proper user experience. Now discussing the real-world application, the system can help users quickly identify whether uh, dishes of which type. It can also recommend dishes based on available ingredients, which is useful in daily life. Additionally, it can assist in dietary awareness and can be extended for application like diet planning, restaurant recommendation system, and health monitoring platform. To conclude, this project combines machine learning, natural language processing, recommendation system, and user interface design into a complete intelligent system. Thank you for watching. I hope you found this explanation helpful.